This video is to teach you the idea of phase difference between waves. It's actually path difference because we're going to get waves to travel different distances, so that's known as path difference, but you'll see the effect on the screen in a minute. So what I've got here is two microphones with their back to me at the moment and a loudspeaker hidden behind the baffle, and what we're going to do as a spin round is, from the other view, we have our two microphones there and we have our oscilloscope with its screen. So what we're going to do is play 800 Hertz notes, which is quite annoying, but you'll be able to do some of the mathematics with it so you can see the difference. So I'm going to turn on the sound, and there you go, you can see it's quite annoying, but on the screen what you can do is you can see that the waves are what we call in phase. They're both going up, but at the same point they're both going down. So I've got one here, that's my left hand microphone, my right hand microphone. And what we're going to do is I'm going to slide one of the microphones further forward, and as we slide that, if we go back to the screen, you can see it slide along. I'll stop it every now and then. And it's getting smaller because it's slightly quieter, but you can see just about there, the peaks of one now line up with the troughs of the other. So what I've done is the distance between those is half a wavelength extra. So our wave has done half of a cycle further. If I take it one more step, a bit too far, then we can get the peaks to line up again. There we go. And so one's gone an extra full wavelength. Now I'm going to turn the sound off, just in case you couldn't hear. So this distance between that position there, which is the 10 centimeter mark, and the 53 centimeter mark is the distance that it takes to do a full extra cycle. That's a complete wavelength extra. So 43 centimeters. My setting over here on my signal generator is a shade over 800 Hertz. So that's 810 Hertz. And if you put the maths in, with the extra wavelength, you could actually work out the speed of sound through air. But yeah, if I turn them back on, again, we'll look at a close-up. What happens is I slide the two microphones, so they actually have the same distance of the wave travel. Okay, so close up, it's going out of phase until they're both at the same position. Okay, so both peaks are lining up roughly. And that's what we mean by phase difference. How much further along the cycle, yeah, it's gone to get from one peak to the next. And it all depends on how far you move the microphones. Okay, there we are, back in phase. Both peaks line up, both troughs line up, and that's because both microphones line up.